And we're back. It's COMP392 and it's week 2, lesson 2, part 2 of the winter 2016 semester. And this is the second part of our broadcast. We did a little bit of TypeScript today, more than we did last week. And the reason for that is because, one, as a refresher, kind of a reminder of what we did, and we need to talk TypeScript in order for us to do more complex applications. So I'm going to bring up my code as some examples. I want to talk about the examples from the PowerPoints. I'm not going to talk exactly to the PowerPoints right now for chapter 1. And these are the examples we brought from last week, so it'll be under lesson 1. If you actually read the PowerPoint at all or reviewed it at all, we covered most of it until we got to about back here. When we started talking about our rendering and viewing an object in 3D, right? So a couple things to note, right? And we'll talk about this. A plane, again, two-dimensional rectangle, right? For those people who don't remember. A cube, three-dimensional cube. We'll render this one in red. A sphere, rendered in blue. Camera, which determines what you'll see in the output. And the axis, X, Y, and Z. And we have a little tool, a little helpful debugging tool that we're going to build with our axis helper. That's what we're going to make. And what we want to do is we want to make this, right? This little thing right here. We want to start with this. And if you look at online, if you go to COMP392 lesson 0, lesson 1, part 1, up on Github, right? So if I was to see where that is, and if I went to Github for a second, and if I was to look at Centennial College, I have these examples online, and I'll be building additional ones as we go. Notice that I have part 1, 2, and 3 built of lesson 2, which is for today. We're a little bit behind, but that's okay because I want you guys to get everything. So if I go to lesson 1, part 1, you can certainly download this and use it. Now there's one proviso. How do I download this from GitHub and use it? Is it ready to use right from the get-go? The answer is no, right? It's missing the lib folder under the scripts folder, right? It's got game and all that stuff. It's got all the code, but it doesn't have the library for Three.js. You're going to have to download and install Bower and do a Bower install, right, in order for you to get this going. So there's a bit of a trick to it. But let me show you how it's done. So let's say, for example, I want to download my code from online. This is a bit of setup too for today. So here I am. I'm downloading my zip file. Let's do it together. So I'm up here on my thing. I'm downloading my file. I'm going to put it on my desktop, on my messy desktop. All right. So I'm going to include this COMP392 lesson 1, and look at it. It comes down in a master zip. It says, right. I can rename it here on the URL if I wanted to, or I'm just going to accept it. Let's just accept it. Okay, cool. So let's take a look. I mean, I've got this the stuff here. I'm just going to close this fireworks off here for a second and kill some of these drawings that I made earlier today, right? And here we go. Just move them to trash. I've got this, zip file, and I'm just going to double-click and extract it. And on Windows machines, you'd have to extract all. And then I have this folder, right? Here's my folder, but it's not going to work, right? Because even though I have a bower.json file, under my scripts folder, I don't have a lib file, right? I need a lib folder in order for me to have my Three.js and all that stuff working, right? So it won't have that. How do I include it so that you always have it? Well, I've got to go into this. The easiest way to do this is launch Visual Studio Code. So I'm going to kind of get Visual Studio Code here. I'm going to close it down for a second. Let's launch it over here. And under Visual Studio Code, I want to get this folder I just downloaded and just drop it into the right pane here, right? Visual Studio Code. Now you have what I have. I have this. But however, it's still not functional. How do I make it functional? I'm going to right-click on here and go open in command prompt, right, for Windows machines, or open in terminal for Mac users, right? And when I do that, let me just make sure that works properly. Hold on a second. Sorry, I had this closed. Open in terminal. So when I open it in terminal, what it's going to do, sorry about that, what it's going to do is going to point to that folder, right? And what I need to do now is do one of these, Bower install. And what Bower install does is it takes a look at, and press enter, it takes a look at the bower.json file and says, oh, look what I need. I need Three.js, .GUI, stats.js, and something else that we haven't touched yet called 3x colliders, right? I want all these libraries, and I want to put them in scripts.lib, right? Because we know where that is. It's coming from our bower.rc file. Our bower.rc, or control file, tells Bower that our Bower directory is called scripts.lib, the lib folder inside our scripts folder, which is here now, right? Okay, that's one piece that's missing. Piece number 2, we don't have any typings. We don't have any type definition libraries. In order for us to get type definition libraries and to start working with this file, I need to go into my terminal and I'll just clear it for now. And I need to type in tsd install. It's like Bower install. It'll go out, grab the type definitions it needs, and install them inside of a typings folder. Here's my typings folder, right? If you don't have this, you know what? Your stuff isn't going to function properly. Okay, cool. Now that I've got everything, I could certainly run HTTP server here, right? Like this. This is one way of doing it, HTTP server. And again, this is something you'd have to download and install. And notice that it's available on port 8080, right? So I'm going to run, actually look at my address is 10.24.23.66. And if you're part of the 10.24.23 network, you should be able to see it, what I've just put up. And you know, it's on the network, right? Now I'm on the wireless, so chances are you're not going to be if you're wired, right? But if you're on the same network as me, the same subnet, right? Then you're golden, right? Chances are you're not. Okay, so let's try this out. Let's do it locally. So I'm going to go to, I'll open up a new incognito window. Why would I run an incognito window with Chrome? Why bother running incognito? I'm pretending to be another user, but also I don't want to cache any of my results, right? Sometimes caching can mess us up. We think that it's not functioning or we haven't saved everything, but actually it has. But our web browser is caching. We don't want that to happen, so we run an incognito mode, all right? That's why I recommend Chrome. And there's others that have the same kind of idea. Incognito mode is the way to go. We don't want to cache anything in our browser. Okay, cool. So now I'm going to type in localhost to test this, 8080, right? And I should get what? And I just did exactly. I went up online, grabbed the files I put online, and I did this, right? So now we have a couple of objects. One that's in, both of them are in wireframe. And we also have this object here, right, which is our axis helper, right? This is the, look at how it's green here. Green, and then there's this axis and this axis. Okay, and this is very interesting because each axis has a different color, right? And I want you to notice how this is oriented. What was the green axis in Blender? Does anyone remember? The y-axis, right? And the blue axis was actually the z-axis. Here, is it still the blue axis in the y? You don't know, right? We have to figure this out, right? So let's check this out. Let's go back into Visual Studio Code and see what we did here. Let's look at our script to make this go. Well, first remember that whenever we do anything with the web, we need to have an index.html as a document to tie it in together, right? Notice how I'm not using an IFI here. I'm using an onload function to make it easy for you guys for the first time to see it. So I'm using the onload function to call the init function, right? So when the body, on the attribute onload, when the body finishes loading, that's what this means, call the init function, right? So when it loads, call init. Well, the init function's inside one of these other JavaScript files, right? Here's my objects.control.js. Well, I have it here, but there are no controls here. I've included it in my library because we're going to build on this thing, right? But there are no controls. Okay, let's take a look. So what's my game.js? Everything is going to be called game.js, but it really doesn't have to be. It could be called app.js or my.js or whatever you want it to call, right? I've just called it game.js because I'm taking the game context as something that I'm using. Notice that my game right now is in the scripts folder. So here's my game.ts file. Oh, there's so much in the global namespace here. This is crazy. But I do use the import. Here's where I use the import like I told you before. And if I hover over the import, because I'm in my TS file, it's telling me that my scene is actually an alias for 3scene. So whenever you see scene, I don't have to go 3.scene, 3.webgl renderer, 3.perspective camera, 3.cube, blah, blah, blah. I just renamed them all, right, as aliases. That's what the import is doing here. right? So I could have used the var keyword as well. And if you notice, when I transpile, JavaScript converts these into vars. Okay, that's all it does. Now there's a way better way to write this, and I want you guys to think about this. How is it better I can write this? I could use an iffy, right? I could surround this whole thing with an iffy, self-executing anonymous function, right? I could do that. And then that would protect the global namespace, the global scope, right? And it's better for us to do this. But for today, we're not going to do that, right? Because it's just too much. All right, so I've made some aliases, and that's what this thing is. And if I was going to document it, these are just aliases. That's what they are, aliases for 3JS, right? So you don't have to use the 3 keyword, right? The 3 namespace, right? Because we talked about referencing them as if they're separate modules, right? Okay, now I've got a bunch of variables. These are actual variables, and the scene variable is my first one, right? My scene variable. I need a new scene. The first thing I need to do is instantiate a new scene. Think about the scene object as a container, right? It's a container object that contains everything else. It contains your lights, it contains, right, your camera, and it contains every other mesh that you instantiate in the scene. You could have multiple lights and multiple cameras and multiple meshes. That's why in the question I asked you, it said lights, cameras, meshes. It didn't say light, camera, and mesh. You can have as many as you want, right? Okay, cool. That's the first thing I do in instantiate. The second thing is I have to set up the renderer. Now I made a method or a little function for that here in our boilerplate. And if you look down here, I set up the renderer. And what am I doing here? I'm calling a new 3JS renderer. Remember I made the renderer an actual 3JS renderer. And this is why I like TypeScript. It gives me all this code hinting, right? It tells me what it is. It says parameters, this is an optional object with properties defining the renderer's behavior. So I'm making a new renderer, and I'm setting the clear color, the background. I'm setting up the window size. I'm setting up if my shadow maps are enabled, which is true. And then I'm printing out to the console saying, hey, I finished setting up the renderer. That's all it's doing. I need a renderer to set up my scene. Scene first, then renderer. Typically what I like to do, and you don't have to do this because camera is just an object, I like to set up my cameras next. That's my third thing I want to do. So first my scene, then the renderer, then the camera. And my camera has a method too, if I flip down here. My camera, I have to decide what kind of camera I have. Remember, there's 2 types of basic cameras, perspective and orthographic. What's orthographic? What do I get when I look at an orthographic view? I kind of showed you guys this with Blender. What do I get with an orthographic view? A what? How about the guy in the back? A what? Flat. I like that. So perspective gives us our line of perspective, our lines of perspective. Orthographic gives us a flat view. So there is no perspective at all. It looks like it's a flat surface. You're only looking at it from one side. The top, the right, the side, one of the sides, the bottom. That's what orthographic camera does for us, right? So typically, in this particular instance, we're using a perspective camera. Here's something that to note, if I hover over, it gives us our FOV. What does FOV possibly stand for? Anybody who understands cameras? Huh? Field of view, right? So the wider my field of view, right now it's 45 degrees, right? If I increase my field of view, what does it do? It renders more, right? It just increases, but it actually creates a weird effect. That's why our field of view is 45 degrees, right? I can go to 60 degrees, but as I keep going wider and wider, it keeps skewing the way it looks like. It's almost like our camera becomes almost like a fisheye lens, right? Be careful with that, right? That's one thing that it does as an option. The second option is the aspect, right? And notice that our aspect is a number that we get by dividing our window width by our window height, right? And the window is actually a variable that belongs to the window object, right? So we're taking our window object and saying, what's our inner width of the window? The width, 640 pixels, let's say, as an example, and divide that by the height to get a ratio, a number, right? What was that? Yeah, 4 by 3 or 16 by whatever, 16 by 9. We want to get that ratio. And then what we do is, but it's more than that, right? We can actually specify exactly our, we don't have to make it so it's the whole window. We can make it 640 by 480 if we want, right? or 1024 by 768, or whatever you choose, right? Whatever ratio. Okay, here's the next one. Here's the next one. This thing. We have a number that's near, right, and a number that's far. What is that? What's the near and the far number represent in the camera? We're going to talk about that not next week, but the week after. But I'm just trying to see if you guys know what near and far might mean. It's the culling mask, all right? So think about it this way. Anything closer than 0.1 units, I can't see it. Anything farther than 1,000 units, I can't render it. I can't see it. That's what it is. So this is my range. I can change the number so that it's not 0.1. It's 10. So I can move my camera so that it can only see anything from 10 units and further out from 10 units if I want to do that for some reason, right? I can modify those numbers, and it's good because sometimes when we use multiple cameras, we may want to have one camera look close and the other one camera look far for different reasons. For example, if I have a gun, my gun camera can be the one that's looking close, and my other camera can look farther out, and it culls my gun. It doesn't render my gun. So you need two cameras, one for the gun and one for the player. Okay? And they layer. They layer on top of each other, okay? Which is kind of cool. So that's what this is. That's what this perspective camera is. I set up this position, and I set up this method called look at. And what look at does, it actually swivels the camera to wherever the scene is, which is the center of the scene, X, Y, and Z, right? I could specify another value in here, a vector that I can look at instead of this. So I've set up my camera. I've set up my renderer. I've set up my scene. Now I want to set up my axis helper, right? And what an axis helper is, it's built into Three.js. It sets up the axis. That's all it does. Notice that it has a value here, the size. How big in units, in Three.js units. It's 20 units wide by high and so on. You can make the axis helper as small as you want to kind of show you where your axes are, right? Which way the blue, red, and green axis is looking, right? To give you an idea, right? And it also gives you a perspective of how the plane is tilted and so on as well. And where your camera is in perspective, in context with the axis. So if you notice in our scene, going back to what we were rendering, the axis isn't flat on. It's actually at an angle, right? Tilted towards us, right? Okay, so that's our axis. And then we have to use the scene.add because the axis is just an object, just like everything else. Our add method, what it does is it adds an object to the scene. The scene, think about the scene as a display list, just like it is in Create.js, by the way. If I add objects to the display list, I can keep adding them. And it creates a list, an array of objects that are in part of our scene. The more objects I add, the larger my array gets. I can keep adding different primitives, cubes, spheres, cones, whatever, right? As many as I want, and it's going to add to that array. The array size is going to grow, right? So that's what it does. Whenever I use the add method, it pushes an object into the array, which is part of the scene container. Okay? I want you to think of it that way. All right? Okay, so here's in order for me to add an object, I need two pieces. I need my geometry, what the object looked like, and almost like a template of what my object looks like. And then my material. Remember we talked about the material shrink wrapping the object, right? Material it tells us how my light will be absorbed and reflected. That's what the material does. And also, do we have a texture as a container? Does it contain a texture? Does it contain another image that wraps around the material as well? That's what the material allows us to do. In this case, the first material is a basic mesh material that doesn't have the ability for it to reflect. Okay, and now we set up this new object, a new mesh, and we pass in those two objects. Every mesh in Three.js needs two objects, right? Question on your test next week, right? It needs a geometry and a material. You don't have a geometry and a material, don't have a mesh, right? Those two things. And then we can choose to turn on shadows or not. In this particular case, even if I turn shadows on or receive shadows, it doesn't matter because we're using a basic mesh material that doesn't care about shadows, okay? We attach the X and Y and Z coordinates, right? So the X coordinate is 15 away from the center of the world that we're looking at. 0, 0 for Y and Z, so it's not up and down. And then what we're going to do is we're going to rotate it minus 0.5 times math.pi. When I multiply something with math.pi, what kind of units am I getting back? For those people who are math people, before I kill you guys with this unit question. Huh? Radians, right? This is not an angle in degrees. This is an angle in radians. Okay, keep that in mind, that rotations are always in radians, or Euler units, if you will, because that's the same thing. Eulers are in radians. Okay, and then we're going to add that to the scene as well. We're going to take our plane and use the add method to add that into the scene. So now we have two things in the scene. We have our camera, right, which is the first thing we've added in. Oh, sorry, three things. Our axis helper, right, and then we added in our plane. So that's the third thing we've added into the scene, right? We do the same thing with the cube. If you notice, the cube is very much the same, right? So here's our cube, and we position the cube just like we normally did. We did the plane, right? So there's our cube. Notice we did the same thing for the sphere. Every geometry is slightly different. If you notice, if I hover over the sphere geometry or the cube geometry, I get different requested values. The superclass of the cube geometry and the sphere geometry and blah blah geometry is geometry, right? That's the superclass. So there's actually a superclass called 3.geometry that both the sphere and the cube, and the plane all inherit, right? That's the superclass, geometry, right? So once we have that kind of geometry, we can add it to the mesh and we can add it to the scene with the add method. And that's what this is doing, okay? Notice at the end here, I'm using this document.body. I'm using the document object, right? Body.append child. All I'm saying is take, because remember, the document itself is a list. It's a node list, right? The index.html document. And I'm saying append this child to the document. Append this renderer DOM element to the document. That's what it's doing. All right? So when I take all this stuff, I add it into the document. And the renderer is going to render my scene, that's what it's going to do, after it's been added as a child to the document. So these last two lines are required, otherwise you won't see anything on the screen. These two lines. Notice that in this example of the code, there is no light source and there's no game loop. There's nothing to repeat. It just does it one time and it's done. It's static. It produces the scene and it's over. I've got some other examples that I want to go with you next day, right? I'm not going to save this example, but they're all online, and I'd like you to study them before we get together, so I don't kill you, like some of you are dying to get out of here, right? So let's take a look at some of them where they are. Again, I would ask that you look at Centennial College, COMP392. Lesson 1, and there's part 1, 2, 3, 4, 5, right? Those are all the parts we need to look at, plus I also have lesson 2, part 1, 2, 3, just to give you a preview of what lesson 5 does, or lesson 1, part 5, what you get. And I'm going to explain how to make this all work later on, because we do use an external module for this, right? Let's take a look at that. Again, I have it under my, you could download it and install it the same way, but I'm going to use Visual Studio Code here to show you it really quickly. Right, and I already have it rendered. So I'm going to take, in my code archive, I'm going to grab lesson 5, or part 5, and drop it in there so you can see the final version of what it's going to look like. And now I'm going to right-click here in Visual Studio Code and go to the folder, so open in Reveal in Folder if I want to. And instead of using this little terminal that I had before, right, I'm just going to double-click on it because most of these things can work right from here if I just double-click. So this is what you get, right? This same scene we're going to build. And how is this all done, right? You have a little control module over here that can increase the rotation speed of the cube. How come the cube is rotating that weird way? Anybody have an idea? It's on a loop, but why is it kind of weirdly doing that kind of thing? Yeah, it's kind of weird, and it shouldn't do that, actually. We have to figure out a method. We have to solve the problem, so make it completely rotate over and over again, right? That's one. The other thing is I can increase the bouncing speed, right? I can go keep accessing it until it's forever. And you're going to still see that from a frames per second perspective, right, we're pretty darn good. If I even increase the rotation to like its max, right, I'm still not losing any frames here. I'm not dropping any frames locally, which is kind of cool, taking into account that it's all, we're using a WebGL renderer for this bouncing ball, right? So this is the final result we're going to talk about next day, and we're also going to talk about assignment 1 And that's it for me for today. Thank you so much for showing up today, guys. I know that we did a little bit of TypeScript, just as a recap, and we talked about some 3JS stuff. I'm going at this slow because I want you to understand the code as we go. Okay? Questions before we go for the day? Anybody? Yes. It's my first initial last name. My first initial last name. So if you have me on, if you look up on, look me up, it's T and last name Tsiliopoulos, right?
Oh, and it was geometry plus something.
Geometry and what else? What's the geometry and material, right? Geometry and material. You bring your mesh together and it gives you geometry and material, right? Hold on a second.
Yeah.